Happy morning to all. Hope you are all doing good. In this session, we are going to discuss about UV visible spectroscopy. UV visible spectroscopy is an analytical technique used to measure the absorption of ultraviolet and visible light by a substance. Ultraviolet means 200 to 400 nanometer. Visible range is 400 to 800 nanometer. It is based on the interaction of electromagnetic radiation with matter, resulting in electronic transitions of molecules or atoms. The technique provides qualitative and quantitative information about compounds. When UV or visible light is absorbed, electrons promoted from lower energy orbital to higher energy orbital. Let's see the principle. The basic principle of UV visible spectroscopy is governed by Beer-Lambert's law. The amount of light absorbed is directly proportional to the concentration of the absorbing species and the path length of the sample. The absorption occurs due to electronic transition such as sigma to sigma star, n to sigma star, pi to pi star, n to pi star. Sigma to sigma star transition has high energy, whereas n to pi star has lower energy. Let's see the instrumentation. The UV visible spectrophotometer consists of the following main components. First one, light source. It provides continuous radiation over the UV and visible region. Deuterium lamp is used for UV region. Tungsten or halogen lamp used for visible region. Next, monochromator. It separates polychromatic light into individual wavelength using prisms or diffraction gratings. It allows selection of specific wavelength to pass through the sample. Next, sample and reference cell. Usually, it is made by quartz. One cell holds the sample solution and the other contains the reference, that is solvent. Next, detector. It measures the intensity of transmitted light and converts it into an electrical signal. Common detectors used are photodiode and photomultiplier tube. The last one is recorder. It records absorbance or transmittance versus wavelength to give an absorption spectrum. Let's see the working mechanism. The light from the source passes through a monochromator which isolates the desired wavelength. The selected light beam is split into two parts. One passes through the sample and the other through the reference. The detector measures the intensity of the light transmitted by both paths. The spectrophotometer compares the two signals and calculates absorbance. A plot of absorbance versus wavelength is obtained, showing characteristic absorption peaks of the compound. Let's see the applications. Identification of compounds, determination of concentration, determination of presence of conjugation, used in quality control for drug assay, purity testing, and stability studies, measurement of nucleic acids and proteins in biological samples, monitoring pollutants or trace elements in water samples, used to study reaction rates by monitoring absorbance change with time. Next, advantages. It is simple, fast, and non-destructive method. It is high sensitivity and accuracy. It applicable to both organic and inorganic compounds. The limitation of UV visible spectra is it is not suitable for the compounds that do not absorb in UV visible region. Next, interference due to impurities or solvents can affect accuracy. It requires transparent solvents and quartz cuvettes for UV analysis. Hope you understood the UV visible spectroscopy. Thank you.